Okay, here's another partial fractions decomposition. A little pause there. My denominator, notice I can get greatest common factor of of an x out. So my numerator stays the same. And now I'm going to take an x out. X squared plus 2x plus 6. So that means I write it a linear factor just has a constant above it, and since this is a quadratic, we write a linear as the numerator. And that's a plus there. And then I multiply this whole thing by x times x squared plus 2x plus 6. So I get 3x squared minus x plus 4 is equal to a times the quadratic. And bx plus c times x. So the most convenient thing is to use x is 0. Then that term goes away. So let's let x equal 0. So these all cancel. So I get 0 minus 0 plus 4, which is a times 0 plus 0 plus 6, plus b times 0 plus c times 0. So this term all goes away. So I'm left with 4 equals 6a, and a equals 2/3. Unfortunately, there's no value of x that I can plug in here, no nice value of x that I can plug in here and make this go away so I can find out what b and c are. So the next thing, unfortunately, I have to do is just to choose another arbitrary value and see if something nice happens. So we did x equals 0. We obviously can't do that again. So let's let x equal 1. If I let x equal 1, I get 3 minus 1 plus 4 equals, well, I know a is equal to 2/3. So that's 2/3. So that gives me 1 plus 2 times 1, we'll make that 1 squared, plus 6 plus b times 1 plus c times 1. So this gives me 6. 6 equals 2/3. This is 1 plus 2 plus 6, so that is 9, plus b plus c times 1, so just b times c. So this is 6, so this is 2/3 times 9 is 6, plus b plus c. So I subtract 6, so I get 0 equals b plus c, or b is equal to negative c. So let me pause and move down a little bit. Okay, so I just rewrote our partial fractions so far with the a being 2/3. We did x is 1, so probably the next easiest value is to let x equal, negative 1. So I get 3 times negative 1 squared minus x negative 1 plus 4 is equal to 2/3 negative 1 squared plus 2 times negative 1 plus 6 plus b times negative 1 plus c times negative 1. So here I get 3 times 1 plus 1 plus 4 equals 2/3. 1 minus 2 plus 6 plus negative b plus c times negative 1. So 3 times 1 is 3, plus 1 and 4 is 8. 2/3. 1 minus 2 is negative 1, plus 6 is 5. And then I distribute this negative 1. So that's really, let's change that to a minus. I'm sorry, that's actually plus b minus c. So this is 8 equals, let's make that 10/3. Plus b minus c. So if I subtract 10/3 from both sides, actually I don't want to do that. Smarter thing to do is multiply this whole thing by 3. So I'll give myself a little bit of room here. That gives me 24 equals 10 plus 3b minus 3c. Subtracting 10 gives me 14 equals 3b minus 3c. We know that b is equal to negative c, so I'm going to put in 3 times negative c minus 3c. Oops, that's 3c. What's that? Why is that in E? So 14 equals negative 6c. So c equals negative 7 over, what's that, 3? Yep. So that means b is equal to 7/3. So my final answer, squeezed in over on the side, is, let me get this, here it is. So my final answer is 2/3 over x plus c is 7/3, so that's 7/3 x minus 7/3 all over x squared plus 2x plus 6. I'm going to multiply this one by 3 over 3 and this one by 3 over 3. So I get 2 over 3x plus 7x minus 7 all over 3 times x squared plus 2x plus 6. Not imperative to write your answer this way, but this is a little more interactive. I'm actually okay with the answer being like this with a complex fraction, but this is just more attractive to look like, and it's easier to manage when you have to do further problems with integration. It's easier if it's in this form. Okay, that's the end of that partial fraction.